Hey guys, welcome to this page of the notes. What we've got here is one more problem where we're going to use the criteria for showing that a figure is in fact a parallelogram. So here we go. I want you to describe three different ways. Give me three different ways that you can show the quadrilateral I've given you here, quadrilateral ABCD, is in fact a parallelogram. Now, I don't have the vertices lettered, so you could go ahead and quickly do that yourself. A, B, C, and D. We need three different ways to show that this quadrilateral is in fact a parallelogram. Okay, well, the first one was I needed to show that, right, one pair of opposite sides are congruent. Well, I do. Sorry, it may be a little bit fuzzy for you guys looking at it. I do have hash marks here on this guy, and those hash marks are simply this. I got a double hash mark on those guys, a single hash mark on those guys, and so here's what those hash marks tell me. That tells me that AB is congruent to side CD, and that's good enough, right? AB is opposite CD, those are opposite sides, and the diagram tells me that they're congruent. So I have one pair of opposite sides are congruent. Good enough. I have one pair of opposite sides that are congruent. I know that this figure must be a parallelogram. That's good enough. You could have also done AD is congruent to BC. You could have done that one as well. I know that those opposite sides are congruent. Once again, one pair of opposite sides must be congruent. Okay, so that's one way. What about another way? Well, the second way I could do this is simply this. Please notice, hopefully you can see in the diagram there, that I've told you that angle, right, that little box means 90 degrees. Well, I need opposite angles. So I know that angle A and angle C are opposite angles. I know that angle D and angle B are opposite angles. I need those opposite angles to both be congruent. And sure enough, looking at the diagram, that is exactly what I see. I know, thanks to the diagram, that angle A is congruent to angle C. They're both 90 degrees. I also know that angle B is congruent to angle D. They're both 90 degrees. Since both pairs of opposite angles are congruent, must be a parallelogram. Both pairs of opposite angles are congruent. Okay, so I asked you for three different ways that you could show that this quadrilateral is a parallelogram. There's two of them. We need a third one. Well, what's another way that I could do this? Well, here's another way. Again, I know, right, that I have parallel lines. How do I know that they're parallel? Well, let me extend those parallel lines right here. I have a transversal. So I have parallel lines cut by a transversal. How do I know they're parallel lines? Well, we have the same side, interior angle theorem, which tells us the same side interior angles must sum to 180 degrees in order for the lines to be parallel. In this case, they do. So here's that third way I can prove this. I know that angle A plus angle D sums to 180 degrees. A is 90, D is 90, 90 plus 90 is 180. So, thanks to same side, interior. Angle theorem. I know that AB is parallel, sorry, I was drawing the congruent symbol. AB is parallel to side CD, and therefore, because those opposite sides are parallel, it must be a parallelogram. So there's three different ways that I can show the quadrilateral above is a parallelogram. There are other ways. Those are just the three that I came up with. Hopefully, please keep going. Come up with a couple others on your own if you can to show that that quadrilateral is a parallelogram. And that's really what the point of this set of notes was, right? Remember, our central question was, how can you show that a quadrilateral is a parallelogram? We just looked at several criteria. If you can prove one of the criteria, then you know that that quadrilateral is a parallelogram. Guys, thanks so much for joining me for this set of videos. I had a great time looking at quadrilaterals and parallelograms with you. I'll see you next time.